All right, let's do this last one. We're going to complete the table for y equals, well, f of x equals 4. Let's just stop right there. This is exponential. The coefficient of this exponential term is 4, which means my y-intercept is 4. So 1, 2, 3, 4. I know that much. Hey, why not? Let's do it. 1, 2, 3, 4. There we go. We know that, right? May as well. All right, we're going to plug in a 1 into this function, and when we do, we'll do this one in our head. The rest of them aren't going to be quite so easy. But when we plug in a 1, we're going to have 4 times 0.75 to the 1, so 0.75. That's 3/4. 4 times 3/4 is 3. Okay, so you plug in a 1 and you get a 3, which means 3/1 is a thing. So far we have a lovely little line right here that means absolutely nothing. It really doesn't mean anything mathematically that those were in a straight line. 4 times 3/4 squared, and now the calculator comes out. We could do this one in our head. Actually, let's do this one in our head. Sorry, I said do. 9/16. 4 cancels with one of these 4s. That gives me 9/4. That's 2.25. Okay, 2.25. Now it gets a little tricky. So 2, and then 2 1/4. So now 2 1/4 goes up to 2. It's a funny looking little thing, isn't it? All right, let's plug in a -1. Let's start using the calculator. We have 4 times 0.75 to the -1. That's going to give me, oops, that's not it at all. There we go, that's better. 5.3 repeating, that's 5 1/3. 5 1/3. I like this one because it looks linear, but it's not. -1 and then 5 1/3. So if I connected these blue dots, I would be tempted to say, man, this is a straight line. It is not. It is a curve. Slight curve in the area we're seeing it. 4 times 0.75 to the 3, that's this one down here, 1.6875. 1.6875, okay. 3, comma, 1.6875. All right, so now we need to just kind of look at this and say, oh, that looks like a straight line, but it's not, and recognize that. I have some red dots that might confuse what we're doing, but I'm going to hold off on the rest of those red dots temporarily. And let's connect the blue dots, but connect them in an exponential way. Okay, growth or decay. What's happening here? Are we going to have a graph that goes up or down? I think we can tell already, but let's look at the equation and tell. 4 times a number smaller than 1, a number between 0 and 1 to the x. A number between 0 and 1 to the x, that's decay, right? A number greater than 1 to the x, that's growth. So this is going to be decay. And so it's not going to touch the x-axis. It will hover above the x-axis, but it will hover above the x-axis on the positive side. So we're going to do that right here. Now we could get into the weeds of where are the other coordinates and when does it really start to look like it's hovering and all that, but just hover it. And what's the next coordinate? Actually, I'm kind of curious about where the next one should go on this end, so I'm going to do that. 7.1 repeating. There we go. So about right there, and then we'll go from that. So not as sharp as some of the other ones. When we draw the inverse, I'm not going to get too technical about some of the other coordinates, but here's what I do need to know as I draw the inverse. I need to be careful that I do not cross, not the x, but the y-axis. So you will get very close to, but not exactly touch, and I'm not reversing all the coordinates, but will not touch the y-axis. And then it's going to do this thing over here on this side. I may not have all the coordinates correct, but the general shape is right. And we will go ahead and find domain and range. Domain, range for f, and f inverse. Okay. Blue graph, original graph. I could plug in any x value I want. I can see that also. I go all the way to the left, all the way to the right, so -infinity to infinity. Let's cheat. The domain of the original is the range of the inverse. The range of the original is the domain of the inverse. So the lowest the blue graph goes is 0, but not including 0. I will never, ever, no matter how hard I try, get a true output of 0. Calculator may tell me so, but it will not be. From 0, not including 0, to infinity, which means this one goes from 0 to infinity for its domain, which makes sense. I'll never touch the y-axis, but I do go forever to the right.